Question number 36 says that an observer moves toward a stationary source of sound with speed 1/10 of the speed of the sound. The wavelength and the frequency emitted by the source are lambda and f respectively. The frequency and the wavelength observed by the observer are respectively. This is the source which is stationary, and somewhere here is observer, and observer is moving toward the source. As observer moves toward the source, there is no change in the wavelength, so lambda would be the same. But yes, by Doppler effect there will be frequency change. The sound will come from here and will cross the observer, and the observed frequency is equal to real frequency into velocity of sound relative to observer. So this would be added up and divided by velocity of sound relative to the source. So this is n and this is v plus v by 10, given that this observer divided by v, this is equal to 11 by 10 of the original frequency. So that is equal to 1.1 f. So look at the option. The fourth option is 1.1 f and lambda. Therefore, the correct option is answer number 4. Question number 37 is an aeroplane is moving towards north at the speed of 540 km per hour and a height of 2.04 km. At a certain instant, the sound of the plane heard by the ground observer appears to come from a point vertically above him. Where is the plane at this instant? The speed of the sound is 340 meters per second. Dear student, what do you find? That this is the plane moving in this direction, and with the speed of 540 into 518, that is equal to 150 meters per second. And from here, somewhere on the ground, a distance of 2040 meter is the observer, and the sound will come from here, will reach the observer. And how much time the sound will take? This is 2040 and the speed is 340. So this comes to be 6 seconds. And what do you find? In 6 seconds, this plane will move horizontally to this point, and the distance covered by the plane during time is 150 into 6, 900 meter. So plane will be at 900 meter from this point because the sound appears to be coming from like this one. So the correct answer is 900 meter ahead of the observer. So answer to this question is the first option. The question number 38 is the end correction of a resonance tube is 0.5 centimeter. If the shortest wavelength resonating with the tuning fork is 20 centimeter, the next resonating length. And dear student, the formula for end correction is L2 minus 3 of L1 divided by 2 is end correction, which is given 0.5 centimeter. The second resonance length you have to find out. The first resonance length is given 20 divided by 2. So therefore L2 minus 60 is equal to 1. So L2 will be 61 centimeter. And the option number 4 is 61 centimeter. So answer to this question is the 4. Question number 39 says the sound level at a point is increased by 20 decibel. But what factor is the pressure amplitude increase? Now dear students, the loudness difference is equal to 10 log of I2 by I1, the formula. And how much is the change? 20. This is equal to 10 log of I2 by I1. So that means 2 is equal to log of I2 by I1, and this was the base 10. Therefore, I2 by I1 is equal to 10 square, that is equal to 100. Now what is the pressure amplitude? The pressure amplitude P2 by P1 would be equal to I2 by I1, the intensity root. So that is equal to 100 root. So pressure amplitude changes by a factor of 10. So therefore the answer to this question is the first option. Question number 40 says, two sound waves originating from the same source travel along different paths in air and then meet at a point. If the source vibrates at frequency of 1000 Hz and one path is 85 cm longer than the other, the nature of interference. Now, dear student, if the power difference is odd multiple of lambda by 2, then you will get the destructive interference, and if it is multiple of lambda, you'll get the maximum. Or you know that if the phase difference is equal to 2 pi or multiply or any multiple of this, like 0, 2 pi, 4 pi, 6 pi, you get the maxima or constructive interference. And if the power difference is odd multiple of, you get the minima. Now, what the relation for this one? Delta phi is equal to 2 pi by lambda divided by the path difference. And now it's given that sound velocity is given 340 meter per second, and so lambda will be the velocity divided by the frequency. So this would be 0.34 meter. If I fill up here, this is 2 pi divided by 0.34 meter, and the path difference is given 85 centimeter, 0.85. And if you solve, you cancel with 17, so this becomes 5 pi. And if the phase difference is 5 pi, so it is the minima or destructive interference. So answer to this question is option 2.